Craig SILLIMAN, its Executive Vice President for Policy and General Counsel, is with us this morning. Please, a big round of applause. Good morning to you, Craig.
Thank you very much. It's great to be here. As I said, my name is Craig SILLIMAN. I'm General Counsel and Head of Public Policy at Verizon. For those of you who don't know Verizon, we're the largest mobile carrier in the U.S. As you just saw from Roland, we also provide fixed broadband services in the northeast portion of the United States. We pass about 20 million homes with our fiber-to-the-home solution, and as Roland noted, we have about a little bit fewer than 6 million customers total. We also provide communication services to businesses and enterprises all around the world. We provide global telematics services, connected vehicles, and fleet management. We have a subsidiary called Oath, which is a holding company for about 50 different brands that we have acquired over the years, including Yahoo, MapQuest, TechCrunch, Engadget, HuffPost, and many, many others. And probably most relevant for this discussion this morning is we're probably doing as much or more than any company in the world in investing in 5G. So one of the questions that's been teed up here, and Frederic just teed it up a little bit here, is 5G versus fiber. I'm going to address that, but I want to start by proposing that that's not actually the most important question about 5G. And it's certainly not the most interesting question about 5G. So I'd like to cover three things here. First, what is 5G? Secondly, what are the prospects of fixed wireless broadband? And third, if we want the development of these networks, what do we need? So first, what is 5G? We've done a little bit of a disservice, I think, and I include Verizon in this, in calling this new infrastructure 5G. You know, 3G in the mobility world replaced 2G, and 4G has largely replaced 3G, at least in some countries. 5G is not going to replace 4G. 4G LTE will be the mobile broadband technology for the foreseeable future. 5G, therefore, really is a little bit misnamed. The way we prefer to think about it is this is a new network architecture, and it is largely built around the needs of the Internet of Things. Francois started the session this morning talking about the tremendous promise of the Internet of Things. We're big believers in that. We do think we're in the middle of a fourth industrial revolution that will be driven by billions and billions of connected devices. But in order for that to happen, just like every other industrial revolution that we have had, you need the underlying framework and technology infrastructure to deliver it. And for that, we need what we call an intelligent edge network. The reason for that is that you will need different types of network architecture for different use cases. Now, this network, it's not a broadband network, it's not the internet. What it is a flexible set of technologies that allow you to tune based on specific network slices for specific use cases. So one Internet of Things use case may require very, very low latency, but bandwidth may not matter. So you can tune the network for very low latency. It may be that another network use is focused purely on battery life, and all you need to do, the network to do, is to go out and wake up a device periodically and then put it back to sleep. There may be other use cases that require big bandwidth. So what you need is this network architecture that allows you to take different slices of the network and apply them to different use cases. And fundamentally, that network will be built around three components: software-defined network in the core, a very deep fiber base, and expansive spectrum and that allows you to deliver both low latency and, when needed, very broad bandwidth at the edge. So when we talk about 5G, again, I think we really need to think beyond the traditional nomenclature of 2G, 3G, 4G, and really think about the future intelligent edge network. So I did talk about one of the use cases potentially as fixed wireless broadband. So let's talk about the prospect of that. So we right now in the US have been testing for over a year fixed wireless broadband in millimeter wave spectrum, specifically the 28 gigahertz spectrum range. We have 11 clusters of tests going on around the United States, and we're trying to test all sorts of different scenarios. So we're testing in cities, we're testing in suburbs, we're testing in single-family homes, we're testing in apartment buildings, we're testing in retail establishments, we're testing in big businesses, we're testing with lots of different kinds of building materials, we're testing in different kinds of weather. Right now, I have a whole bunch of really interesting charts on the results that I'm not going to show you today because we're not talking about this publicly quite yet. We're going to start releasing our results publicly fairly soon, but here's what I will tell you. Everything we have tested so far has exceeded our expectations. We thought that we could probably get propagation up about 6 stories high in apartment buildings. We're so far exceeding that. Our goal was to deliver more than 1 gigabit per second of speed at least 1,000 feet or a little over 300 meters. So far, the tests we're showing are far exceeding those expectations. And very importantly, we are showing that you can deliver more than 1 gigabits per second throughput without direct line of sight, which is one of the things that critics thought was not going to be possible. So we're very encouraged so far in the early test on fixed wireless broadband. Now, does that mean it's a replacement for fiber? What I would say is, it depends. We're not really looking at this as a replacement of fiber per se, but rather another tool in the engineering toolbox. So whether fixed wireless is able to replace fiber really depends on what problem you're trying to solve for. So if you have a direct right-of-way into a customer's site, in many situations, fiber is going to be the best solution. But if you have right-of-way problems over your last mile, if you have problems with landlords, one of the issues that we have seen frequently in our fiber to the home build is it works well with single-family homes, but we have customers who are interested in large apartment buildings, but dealing with the landlord is the big problem because the landlord isn't interested in letting us get in. A fixed wireless solution lets you bypass the landlord and deal directly with the customer by forming connection directly into their apartment. It's one of those issues that seems trivial when described broadly, but can be all the difference in the world between a successful deployment of fiber to the home or not. So right now, what we look at is fixed wireless broadband potentially solves a number of engineering issues. When I say it doesn't necessarily replace fiber, partly because it depends heavily on a deep fiber infrastructure. So one of the things that we are doing right now is investing very heavily in fiber overall. We've publicly announced a contract with Corning. Just the contract with Corning alone commits us to buy 20 million kilometers of fiber optic cable every year for the next 3 years. So if you think about 20 million kilometers of fiber optic cable every year for the next 3 years, you get a sense of just how much fiber we're deploying right now. So put those together. We're talking about 5G fixed wireless broadband, but we're also deploying all this fiber. Why? Because increasingly what we are doing from a business case perspective is looking at how to stack various business models on top of each other to justify the overall fiber build. One of the things when we were looking at our 4G network and the growth of traffic and the need to invest is, how do you handle the traffic growth? And generally speaking, you have a couple of levers. You can acquire more spectrum, or you can densify the network. Densifying the network means simply putting more antennas in a geographic area. And generally, that's just a trade-off in how you allocate your capital. But when you begin to look not just at putting in more fiber deeper into the network for cell densification, but also what are the demands of small businesses? Do they need fiber in the same areas you will build? And then pre-positioning fiber for 5G. working with cities on smart traffic solutions, crime management solutions, where cities increasingly want fiber running to every street light in the city, which is also where you're likely going to need to put your 5G antennas, which is every couple hundred feet. When you do that and you suddenly look and say, if I'm going to deploy fiber through a city, I'm now not going to just deploy one strand to a given home, but I'm going to run 1,000 strands through the city streets, run one to every other street light in the city, and the business case for that is built on top of densifying my 4G network to handle growth in mobile traffic, needs of small, medium businesses, needs of municipal customers, city customers, and then the future of 5G. You begin to look at a very different business model for the massive deployment of fiber and the ability to put 5G in place. So finally, the third topic that I want to touch on is, if you need to do this, we're a fair ways down the road now in the US in deploying this much fiber and pre-positioning for 5G. What do you need? What sort of environment do you need in order to do this? Right now, there are 4 countries in the world that are really moving aggressively on 5G: the US, Korea, Japan, and China. Our lessons so far learned are the following. First, you need a very broad swath of spectrum. You need a spectrum band really with at least 100 megahertz of contiguous spectrum. We talked about, and Frederic mentioned, a couple of spectrum bands in the 700 and the 3.5 that may be available here in Europe. We're looking at different low and mid-band spectrum in the US, but we've really focused on high-band spectrum for 2 reasons. One, you have the availability to get massive contiguous spectrum, so you can get several hundred megahertz of spectrum in a contiguous band, which gives you a massive bandwidth ability. Secondly, if you're doing massive in, massive out technologies, as we look to move to mobile 5G in the next couple years, which is where the real promise is, and that should be coming, we believe, by 2020, 2021, you need to put a huge number of antennas in a very small device. And by using millimeter wave spectrum, you can get much smaller antennas, put far more antennas into a smaller device. So criteria 1 is you need a huge amount of spectrum. And I give a lot of credit to the FCC in the United States of being very aggressive over the last couple of years of getting spectrum out so it can be deployed. The only reason we're well over a year into testing 5G at this point is because the FCC made spectrum available to us 2 years ago in the millimeter wave band. The second big thing that you need for 5G is, as I mentioned, massive amounts of spectrum. Massive amounts of fiber. And when it comes to fiber, as you all know, it really comes down to the day-to-day. 1, what is the investment incentive to build fiber? And then 2, what are the day-to-day issues in trenching the streets? It's rights of way, it's permissions from cities, it tends to be very local, and streamlining that can make all the difference in the world about whether you can get enough spectrum, enough fiber in the market to support 5G or not. It is not big, sexy policy. It is the day-to-day local policy, and it is the most important thing for getting the fiber in place that will be needed for 5G. And then the third big thing is antenna siting policy. Again, not a big, sexy policy issue. It's a very local issue, but it can be critical. Most countries' antenna siting policies were set based on traditional cellular networks where you'd have a big tower with a big antenna broadcasting over several kilometers. In the world of 5G, you're going to have very small antennas placed perhaps on every street light in a city. That's a very, very different kind of permitting regime. Frederic mentioned the expectations of how many times more antennas you will need for 5G. I will tell you, our estimates, it is far, far more than 2 to 3 times the current cellular networks. And so you are going to need to be able to scale at a much, much greater level. And that means if you have a city charging you 1,000 euros per year to site an antenna, that may work in a 3G or 4G world where you maybe have 1,000 antennas. It does not work in a world where you have 100,000 antennas. And so we're going to have to revisit the antenna siting policies. So you need massive amounts of spectrum, you need streamlined fiber build permitting processes, and you need streamlined antenna policies. With these, we think that 5G has tremendous promise. We think 5G could be exciting as a fixed wireless broadband play, perhaps as another tool in the engineering toolbox, but again, the real promise is going to come in a couple years with mobility. It is a fundamental underpinning of the Internet of Things, this future network architecture that ultimately will deliver the fourth industrial revolution. Thanks very much.
Thank you very much, Craig.
Let me just say.